We had decided that we could use the quadratic formula on this problem. We hadn't actually done that. We're going to do that because I need to simplify this with you and go through how to simplify square roots because we haven't done that in a while. So if I'm plugging stuff in here to the quadratic formula, this is our problem that we ended up with down here at the bottom, 4x squared plus 20x minus 25, because we decided to factor out the 3. So if I'm plugging that into the quadratic formula, it says negative b, so I'm going to put what there? Negative 20 plus or minus the square root of 20 squared minus 4 times a, which is times c, which is, okay, all over 2 times 4. Okay, which part of this do we do first? Discriminant, and the discriminant is in the house. So what is, if I put the discriminant in the calculator, the 20 squared minus 4 times 4 times the negative 25, what do I get? I think 800? 800? Okay. So negative 20 plus or minus the square root of 800 divided by 8. Yesterday the question was asked, well, I can divide all these by 4, so it would be like negative 5 plus or minus the square root of 200 over 2. I can't do that inside the square root, but I can simplify my square root. And this is something we did at the very beginning of the year. And there's kind of 2 ways to do this. I'm going to do the way that's the quickest way to do this. So think about the number 800. Are you okay if I say that 800 is really 8 times 100? Yeah. Okay. So I can rewrite this problem as negative 20 plus or minus 10 square root 8. Nope. Just 10. Why? Why just 10? Yes, because the square root of 100 is 10. So I can bring that 10 out. Could I do that? Yes. Yes, because I can, if I think about 8 is really 2 times 4, and the same thing can happen here because I can take the square root of 4. So really it becomes negative 20 plus or minus 20 square root 2 divided by 8. Yes, so you multiply them together. So it was 10, now it's 20. Why is it 20? Because I multiplied 2 times 20. Where did that 2, or 2 times 10, where did I get that 2 from? From the square root of 4. Keep in mind it came from the square root of 4, not from this 2 here. That's important to remember. Okay, that I got this 20 because I did 10 times the square root of 4. And we can do that. And we actually could have done that from the beginning with 800 because 800 is really 2 times 20. Or sorry, 2 times 400. And what's the square root of 400? 20. So it would have worked like that from the beginning. But most of you probably didn't think, oh, it's 2 times 400 and 400's a perfect square. Like that's just not a perfect square that pops in your mind. When you think perfect squares, you think nice numbers like 64, 25. Do what? Yes, that just happened to work out that way though. It was just coincidental. Can I reduce that anymore? I can divide everything by 4. So I really end up with, what, negative 5 plus or minus 5 square root 2 over 2? Okay, so we are saying that this problem has 2 solutions. It has 2 answers. Negative 5 plus 5 square root of 2 over 2 and negative 5 minus 5 square root of 2 over 2. The only problem that we may potentially have is that sometimes these problems have excluded values, and our excluded values trump our answers. So we have to go back and we have to figure out what our excluded values what our excluded values are in this problem. So where do we find excluded values from? Denominators. So anything that was ever in the denominator at any point in time is going to give us an excluded value. Well, my denominators were 15x plus 60, which we factored that and it gave us what? 15 times x plus 4. So that means I'm going to have an excluded value. X cannot equal negative 4 because that was a denominator. I also had a denominator of x squared plus 9x plus 20, which when we factored that, it gave us x plus 4x plus 5. So how many excluded values does that produce? 2, but one of them is already shown up because x plus 4 is going to produce an excluded value of negative 4. X plus 5 produces an excluded value of negative 5. So do those excluded values conflict with the answer that we came up with? It just has the 5 in it, but are these like, because this isn't just a negative 5, it's that whole number. So is this whole number here the same as either of these excluded values? No. So then I don't have to worry about anything. So this answer is correct. But sometimes, and we're going to do one in a second, sometimes when we get our answers, one of these answers we come up with is one of our excluded values. And when that happens, that means that number can't actually be an answer. It's page 546, problem 5. I'm going to figure out the excluded values first. Excluded values come from denominators. So I have two denominators. So I have two excluded values. So what can x not equal in this problem? Negative 3 and negative 6. So we're going to go through and we're going to work this out. And as long as neither of our answers is negative 3 or negative 6, then we're good. So to work these out, the easiest thing and what we learned last time was we cross multiply. So I multiply x plus 1 times x plus 3 equals, and I always multiply bottoms to tops, 8 times x plus 6. Can anything cancel? No. So what do? Foil, distribute, I need to eventually solve. So if I foil, 8 times x would be 8x and then 48 equals, it would be x squared plus 4x plus 3. And you can FOIL that out. Some of you need to go through and FOIL that out every step. If you FOILed it, it's x squared plus 3x plus 1x plus 3. And you can combine that 3x and that 1x together and get 4x. What kind of problem is this? What does it have in it? It's a quadratic. It is a quadratic equation because it has x squared. So the only way to solve quadratics is to get it to equal what? 0. So I need to move stuff. Rule of thumb, always keep x squared positive. It works way better for you if you keep x squared positive, because if this factors, which this one will, then it's easier to factor if x squared is positive. It's more difficult if x squared is a negative term. So if I want to keep x squared positive, what should I move? The 8x plus 48. And to move 8x, I'm going to subtract 8x from both sides. And to move 48, I'm going to subtract 48 from both sides. I'm going to do that all at one time. You could do it separately. You could do one at a time. That's fine. You can do it all at once. It's whatever makes the most sense to you. If I do that all at once, I end up with x squared, or either way, minus, not 5, 4x minus 45 is equal to 0. Now I can solve, and I have two options for solving, really. What's one option that works every time without fail? Quadratic formula. And then, Zach, what's our other option? Yes, factoring is our second option. Does this problem factor? Yeah. It does. And anytime it factors, that makes our life so much better. We like when it factors. Okay, so to find our factors, I do my product sum chart. Negative 45 and negative 4. What things multiply to give me negative 45 and add to give me negative 4? Okay, so that means my factors become x minus 9 and x plus 5. Okay, so if I'm going to solve this now, well, this is where I set each piece equal to 0. So I set x minus 9 equal to 0. I set x plus 5 equal to 0. So that means I have two answers. What's my first answer? And my second answer? Do either of those conflict with my excluded values? So that means I'm good, that I have two answers, 9 and negative 5. So if I plugged in 9 or I plugged in negative 5, then my fraction on the left and my fraction on the right would be equivalent. Problem B on the same page at the top. Ooh, what's wrong with this one?
There's another thing to do.
Yeah, there's another thing that we have to do because this one has, like, what do we have to do first? We have to add them. Oh, our life is so terrible. It is awful. All right, so the first thing I have to do is I have to add the left side. But in order to add the two fractions on the left side, because I can only do cross multiplying if I have a fraction on each side, just one fraction. But I can't do that right now because I have two fractions, so I need to add them. Which means I have to do what? Yay, we love common denominators, don't we? It's not this is not a complicated one though. Like, let's be real. Oh, before we do that, let's figure out what our excluded value is, because that's easy. Excluded values come from which part of it? Denominator. So in our problem, x cannot equal what value? 7. It's just 7. We don't worry about the 2 because the 2 doesn't have an x attached to it in the denominator. So the 2 just means there's a whole number down there. There's not actually an excluded value there. So we know x can't equal 7. So now I need to come up with a common denominator. But this isn't terrible because I don't have to factor anything, which is nice. It's already factored for me. So what am I going to have to multiply this first fraction by to get it to have the same denominator as the second fraction? 2. Okay. What am I going to have to multiply the second fraction by so that it now has the same denominator as the first one? X minus 7. So see, that wasn't terrible. So I'm going to distribute that out. So 2 times 2x would be 4x. 2 times negative 9 is negative 18. Plus x times x would be, and then x times negative 7. And I'm going to put this all as one giant fraction because the whole purpose in me doing what I just did was to get the denominators the same. So there's no reason to write two fractions now because really it's just one fraction. So I'm going to put it over one denominator, 2 times x minus 7, and this still equals 5 over x minus 7. What else can I do? Yeah, I can simplify the numerator because I have a 4x and a minus 7x. What is 4x minus 7x? Negative 3x. So I really have x squared minus 3x minus 18 divided by 2 times x minus 7 equals 5 over x minus 7. All right, so if I'm cross multiplying, 2 times x minus 7 times 5 is really what? Yes, 10 times x minus 7. And then I can do the same thing the other way. X minus 7 times, oh, nope, I can't actually do anything there. So we're just going to write x minus 7 times x squared minus 3x minus 18. And they are still equal. So you said something was going to cancel. What is it that cancels? And why do they cancel?
Because they're repeated on both sides.
They repeat them on both sides because mathematically I could divide both sides by x minus 7 because we learned yesterday, or we talked about yesterday, you can do whatever you want as long as you do it to both sides. So I could divide both sides by x minus 7 and those would cancel out. So now I'm left with x squared minus 3x minus 18 equals 10. So we minus 10 from both sides. Does that factor? We get x squared minus 3x minus 28 equals 0. And that does factor. Yay. I like it when they factor because we don't have to do a lot of work. How does that factor? Negative 7, positive 4. X minus 7 times x plus 4 equals 0. So I get two answers for x. My first answer is 7. My second answer is yes. Okay. Do either of those conflict with our excluded value? Which one? So that means that really this one can't be an answer and I only have one answer of negative 4. Okay, so your homework, I told you to do 3 through 14, correct?
Yes.
And then 23 and 24?
Yes.
Okay, I need you to fix something on 3 through 8. 3 through 8, you're ignoring the instructions that they give you. You are solving. But the problem is, on 3 through 8, you need to replace all of the word ands with an equal sign. On 3 through 8, you need to replace all of the word ands with an equal sign.
So solving for x.
Do what?
Solving for x.
You're basically solving for x on all of them. Yes.
Better not be like really easy.
All right, I'll do problem 8. So we have 3x over 5x squared minus 40x minus 60 is equal to, because we changed it to an equal to sign, 17 over negative 7x squared plus 56x plus 84. So I need to factor first of all. That's always kind of our goal, is to factor first of all. Well, wait, do I need to factor first or do I need to do something else first? Okay, cross multiply and then we can do the factoring part. Alright, so if I cross multiply, I end up on the left side with 3x times negative 7x squared plus 56x plus 84. I'm just rewriting is equal to the right side. I get 17 times 5x squared minus 40x minus 60. Okay, let's factor the right side first, because that one looks a little bit easier. Can you factor 5x squared minus 40x minus 60?
Yes.
What can you do first? Take out the GCF, which is 5. So if you take that out, you still have 17 times 5 times x squared minus, 8x minus 12? Yeah? Okay. Does that factor?
X minus 6 and x minus 2.
Does that work?
No. That'd be positive 12.
It would have to be positive 12 in order for that to work. So that doesn't factor. Ooh, okay, that's going to be interesting. Equals. All right, so then looking at the other side, it has a GCF of... You can factor out a negative 7. Yeah, that would be a great idea. If you factor out that negative 7, then that's going to keep x squared positive. So we'll have 3x times, and I would do a negative 7. So that becomes x squared minus 8x minus 12. So what happened? Those x squareds minus 8x minus 12 end up canceling each other out because I have one on each side. So mathematically what I'm doing is I'm dividing both sides by x squared minus 8x minus 12, because I can do that. I can do whatever I want as long as I do it to both sides. And these cancel. Oh, this works out so well. What is the left side now? Negative 21x equals, what's the right side now? 85. How do you solve that for x? You divide by negative 21. Why don't we need to worry about this one equaling 0? It's not a quadratic. Very good. So my answer is negative 85 over 21. So now I just need to go through and I need to make sure that doesn't conflict with my excluded values. Where am I going to get my excluded values from? The denominator. Okay, which my denominator was these two. Which when we factored them, what happened when we factored those? They canceled each other out, so we need to figure out this, x squared minus 8x minus 12. We got to figure out, we know we can't factor that, but we've got to figure out what x cannot equal. I need to figure out what's going to make this equal to 0. How do I figure out what's going to make that equal to 0? Quadratic formula. I know. I got to use the quadratic formula. Aren't you glad we did this problem?
Yes.
So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. It is a negative 12. Thank you for catching that. Okay, so what's my discriminant? It's what? Should be something positive. It should be positive like 102. Okay. So we get 8 plus or minus the square root of 102 divided by 2?
112.
112. Okay, sorry. Yeah, that makes sense. 112. Okay. That was my bad. I missed that problem. Okay, can we take the square root of 112? No. Not get something nice. Can you simplify that anymore? Think about what we did earlier. We looked for factors that are perfect squares in 112. So 112, what is it divisible by?
16 times 7.
16 times 7, great. So 112 is 16 times 7, which really means that I can make this square root of 112 look so much better, because it will end up being 8, not that 8, this 8, plus or minus, what's the square root of 16? 4, so it can come outside because it looks pretty. Square root of 7, that needs to stay inside because it looks ugly, divided by 2. Can I simplify that at all?
Yes.
How? Divide by 2. So I end up with 4 plus or minus 2 square root 7. So these are my excluded values. These are the things that x cannot equal in this problem, meaning we're either going to have holes or vertical asymptotes on the graph at those two places. Are either of those values the same as what we ended up with as our answer to our problem? No. So that means our answer is good. We don't have to worry about anything. It works out well.